Hello, class. This is a recording of our lecture that we missed on for in class on photoperiodism and circadian rhythms, and I wanted to go over one more concept here about photoperiodism. It's important to understand in how the photoperiod influences and mediates circadian rhythms, and we'll be talking about from the perspective of mammals. That's what we know the most of. It's what we've studied the most. So in 1932, Bissonnette discovered in ferrets that their estrus cycle could be induced in winter by artificially increasing their photoperiod, which is their day length. So how much light they're exposed to in a 24-hour period. And this was the first time that this was demonstrated, the photoperiod having a direct effect on reproductive physiological cycles. Similar observations were made that same year in field voles. In Yates, sometime later, showed that shortening day length induced estrus in sheep. And so we can take a look at this graph here in Siberian hamsters, measuring testes weight, which we've seen before, that testes for a number of different animals, a number of different vertebrates, will fluctuate in size over the course of 1 year. They essentially shrink when it's not the breeding season, which is thought to be an adaptive response. Why maintain this large tissue if you're not going to use it in the middle of winter? And it's not a great time of year to be breeding in like late fall, let's say, if you're a bird, because you're not going to build a nest and try to find insects in the middle of winter if you're living at high northern or southern latitudes, because it's going to be cold and it's going to be impossible to raise young. And so taking a look at here, as you artificially increase photoperiod all the way from 0, so that would be a dark light regime, up to about 12. Once you reach and surpass that threshold, a pretty stark contrast. All of a sudden, this triggers something endogenous. Some physiological switch seems to be, some endogenous physiological switch seems to be flicked on, and the testes grow. In here, you can actually see a fully developed testes and a fully regressed testes side by side from the same species. And the only difference is the one on the left was exposed to long days, the one on the right was exposed to short days artificially. And this brings in a concept known as photorefractoriness. So animals seem to be sensitive to short days. Mammals, specifically, seem to be sensitive to short days. When days start to become shorter and they're not exposed to as much light during the day, their testes will regress. They will stop going through an estrus cycle. They'll stop a whole host of reproductive physiological processes and behaviors in response to short days. But this sort of like turning off the switch of reproduction is temporary. With a long enough exposure to short days, animals will enter what's known as photorefractoriness, where they are no longer sensitive to short days. And in mammals, they will start to gear back up, grow their testes, start estrus cycles, developing into a reproductive body condition, and will start to behave appropriately for reproductive specific behaviors. And so the sensitivity to short days is temporary. They will eventually enter photorefractoriness where they are no longer. So if you artificially bring an animal into captivity that's in reproductive condition, and you artificially shorten their days, and say you bring it down to just 6 hours of daylight every day, and they're in their cage, they will go out of reproductive condition. And let's say you don't do anything to the lights. After a few months, or about 2.5 months, 3 months, they will all of a sudden kind of spontaneously start to move into reproductive condition again. Even if you don't change the photoperiod, even if it's still 6 hours of light a day. So the sensitivity to short days is temporary. They will develop photorefractoriness that they'll move into. And you can show them short days for the rest of their lives, and they will continue to maintain reproductive body condition. So this is known as photorefractoriness. And we see it all over the place, we see it not just in testes growth, but in behaviors as well. Looking both at females on the left and male hamsters on the right, we can see that both males and females will become more aggressive in response to short days. But eventually that wears off, and despite the fact they're still in short days, so SP on the left stands for short photoperiods, but it's the same as short days. In response to short days, they increase aggression, but that eventually wears off. They're no longer sensitive to short days because they've entered a period of refractoriness, and they go back down to their baseline levels of aggression. Another example in hamsters, refractoriness of thermoregulatory physiology. And so that's just a fancy way of saying these hamsters that change their coat color. They're white during the winter, dark during the spring and the summer. And we can see in response to short days, typically what happens is these hamsters will develop a lighter color coat that corresponds with the winter months. And they eventually go into a period of photorefractoriness where they start to develop their darker coats again. It gives them better camouflage during the spring. And they wax and wane like that. Here in captivity, we can see that if an individual is never exposed to short days, they'll never develop that lighter coat, which is the green line on top. And individuals that are held at a constant short day period will experience that change because initially they are sensitive to short days, but then they enter a period of refractoriness and they are no longer sensitive, and they'll go back to their baseline coat, which is the dark color, after a certain amount of exposure to short days. So mammals are able to break refractoriness, right? We know this because every year, right, they cycle up and down in these different behaviors and physiological conditions. And so they must break this refractoriness, right? Because the next year they need to be sensitive to short days again, because this is an adaptive response to shorter days and colder temperatures. So it takes at least 11 weeks of long days to break refractoriness. So once they become refractory to short days and they're no longer sensitive to it, and they go back up into breeding condition in both physiological state and behavior, in order to become sensitive once again to short days in the future, they have to be exposed to long days for a period of time, and that's about 11 weeks, which is about as long as summer. And so this is what it looks like. This is what the cycle looks like. So just starting arbitrarily here at the end of the breeding season, the end of summer. We have a hamster all the way on the left here that is in good breeding condition, and we're measuring here specifically an index of gonadal function, which is a mix of size and functionality and sperm development and sperm production. When they're exposed, as they start to become shorter in the fall, and they pass that critical threshold, and depending on the species, it might be 12 hours, it might be 11 hours, it might be 13 hours, depending on the species and the population. The gonads will undergo regression, which we've seen in response to short days. And they'll spend a certain amount of time there. It's sort of like a ticking clock, right? There's a limited time that their testes will stay regressed. And eventually, they enter a state of photorefractoriness where that short day is no longer imposing inhibition of testes growth, and it spontaneously grows again. This corresponds to the end of winter, beginning of spring, when days are starting to get long again. And they are exposed to long days once again. Of course, early spring, they reach reproductive status. They breed, all along being exposed to long days. And by mid to late summer, they have experienced enough long day exposure where they once again are primed to be photosensitive again. And when they're photosensitive, if they run into short days again, their testes will regress and they'll lose gonadal function. And that's exactly what happens. So if we were to take this hamster, say this second dark hamster, or the third hamster, the one that's all the way on the right, and were to take him out of the wild and put him into an artificial environment in which they never see short days, they will continue to maintain breeding condition. Or let's say we take that hamster all the way on the right and we take them at the beginning of May and put them in an artificial environment and all of a sudden switch that hamster to short days again. That hamster will not it won't be sensitive to the short days. It still is in a period of photorefractoriness because it has not gotten about the 11 weeks of long days that it needs in order to become photosensitive again. So it needs a nice long summer in order to become photosensitive again, so that it responds to short days.